Okay, so we're going to fill out the inside of our foldy for perimeter and area. And we're going to talk about perimeter first. So in the perimeter flap, perimeter is the distance around the outside of a geometric figure. Okay? So when we're looking at this figure, one of the things that I forgot to mark that we'll just talk about is this is called a regular figure, which means that all the sides are the same length. Or you could just put all sides are the same. This is your notes, if that makes sense to you. This is a hexagon. There's not really like a formula to find perimeter of the hexagon. We just have to figure it out. So I have 15 on this side, and then there's 1, 2, 3, 4, 5, 6 sides. So there's a couple of ways I could figure out the perimeter. I could go, okay, there's 6 of them. I could go 15 plus 15 plus 15 plus 15 plus 15 plus 15. Because all of these, because we know it's a regular hexagon, would be 15. That seems like an awful lot of adding. What would be a faster way? Raise your hand if you know. Silas. Multiplying. I could just take 15 times 6. And if I do that, I find out that the total is 90. Now, the crazy thing on here is I don't have any units. Normally we'd have inches or centimeters. Since that's not there, I could either leave it blank or I could write units, the inches, centimeters. It's just a normal length, something you could measure with a ruler or a tape measure, normal units. Okay? So your answers when you're doing perimeter are just normal units, like inches, centimeters, feet, miles, stuff like that. It's just a distance. All right, so everybody got that part? Let's go over to area. Okay, so area is the number of squares of a given size. It should say that fit. I left out a word. That fit inside a geometric figure. And this is not a trapezoid. Sometimes people call it that, but there's no parallel sides. This we'd just call a quadrilateral, quad for 4. It's just a random shape. Now, really tiny over here, if you like really zoom in, you will see there's a little key that says that each square is 1 square centimeter. That lets us know this grid is broken up in centimeters. Let me zoom back out. That was a little too much. Okay, so this is a strange figure. When it's on a grid, or if they draw it on a graph, like on your X and Y axis, you can count the squares. And this is how originally people did area. So we're going to do that really quick and kind of count how many squares are in there. We're going to start with the whole squares really quick. And so I'm going to start here, and I'm just going to put a little dot inside each of the whole squares as we go. Are you ready? So 1, 2, 3, 4, 5, 6. We'll count that one. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38 whole squares. I'm going to write that down just so I don't forget. That's the whole squares. And then I've got some partial squares. And the method that I like to use for the partial squares is I like to think of putting a couple of halves together to make a whole. And they're not all exactly halves, but that's just kind of how my brain works. And so if you look at this big one on the top that's almost a whole one, I could join with this little piece down here to make another one. So that would make another one. I could add that one on. And this one could go together, and that would add another one. And then this one and this one kind of go together, that would add another one. And then we've got kind of a half in there. So I might put, okay, there's a half, or a 0.5, however you want to think about that. And then I would come to this side and do the same thing. So this one and this one would make one, so I'd add another one. This one and this one, I would add another one. And then that one and that one's another one. And this little piece right there really doesn't amount to much, so I'm just going to leave that. So let's count this up. So we had 38, 39, 40, 41, 42, 43, 44 and a half-ish. So it comes out about 44 and a half. You want to use 0.5? Is that more comfortable to you guys? Yeah. Since in centimeters, a lot of times we use decimals, we'll do that. So 44.5. And then this is square centimeters, and they wrote it with an SQ for square and then centimeters. But usually we use centimeters squared. When you're doing area, this notation on the label lets us know that it's not just a straight centimeter that you could measure with the ruler. It's being measured in squares. And make sure you're putting that little squared mark on the centimeters or the inches label. Do not put it on the number. Otherwise, it changes the number and it becomes a whole different thing. Okay? So, let's take a look at how this is going to work. So we're inside the flap for squares and rectangles. All right, so we're going to talk about squares first. So what do you know about the sides of a square? Raise your hands. Brian.
These go to blank is 5 yards.
Good. So all the sides are the same on a square, right?
Yep.
And so if I didn't have those on there, sometimes they'll take in the label, the side on a square, an S for side. How many sides does a square have? Raise your hand. Bennett.
4.
4. So when I'm doing the perimeter, I could add the side and the side and the side and the side together. What would be faster? Tommy?
5 times 4.
Okay, so the side times 4. So I'm gonna, on the perimeter here, I'm going to write 4S as a formula to find the perimeter of a square. Now you could just add 5 and 5 and 5 and 5. That's fine. But that's the formula we're going to use. So down here, so this is up here is sort of, it was supposed to be kind of boxed off. I didn't get that quite written in there. Is the formula. Down here we're actually going to do it. So we see that the sides are 5 yards. So we can just take 4 times 5. And I find that the distance all the way around is 20 yards. Okay? Now, to find the area of the square, I'm going to talk about something really quick and then you can tell me. Okay, so back before we had formulas, people would have to actually take this and break it into 5 yards this way and 5 yards this way and count all of the squares. Doesn't that sound like fun?
No.
No. What would be faster? Tommy was anxious to tell us.
For a square, you could do the side split.
You could take the side times the side, and since they're the same, that would just be the side squared. So in this, I'm going to take 5 times 5, or in other words, I'm going to do 5 squared. It's the same thing. And then my answer is 25. Now we were measuring in yards, but remember, we are breaking this up into little squares. So it's not like a linear yard that you'd measure with a yardstick or a tape measure. We're measuring square yards. So each of these is 1 yard by 1 yard square. So that's how many squares fit inside. And it's good that we have formulas because sometimes the shapes get really crazy and the numbers can be really big and it can be exhausting to draw all of those lines. Okay? So we have a similar concept for rectangles. Now rectangles have 2 sides that are the same and 2 sides that are the same. And we usually call them length and width, or you can call them base and height. Either way. Okay, I still use length and width for rectangles and use base and height for other things just so it doesn't get confusing. It's the same thing. All right, so for my formula, basically I need to take this side times this side. Look, I wouldn't even want to draw the squares in this. There's a 0.3. I'd have to do 0.3 of a inch on there. It'd be crazy to draw. But if I know that, I just have to do that. All right, so for the perimeter on this, I would add this length with this length, and that width with that width. How many lengths do I have? 2. So if I want to do a formula, I can do 2 lengths, and then plus, how many widths do I have? 2. 2 widths. Or I could just add all of these together. Okay? So before I do area, let's just go down here and do the perimeter. So you could think of it as adding 11.3 and 11.3 and 6 and 6. It's a little faster sometimes to go ahead and use this. There's 2 6s, so I'm going to take 2 times 6, and there's 2 11.3s, so I'm going to take it times 2, and I can do that. And so 2 times 6 is 12. 2 times 11.3 would be 22.6. And if we add those up, we get 34.6. And then I need to label so I know what we're measuring in. That's inches. 34.6 inches is a whole lot different than 34.6 miles or centimeters. You want to have those labels so we know what we're talking about. Okay, so area formula, raise your hand if you know it. Brian.
Length times width.
Good job. Length times width. So the length times the width. We've used this formula for a long time. You guys did it in elementary school. It's old hat probably. So we're just going to take that 11.3 and take it times 6. And I did that with the calculator a little bit ago. It comes out 67.8. And then when I label this, remember that we're measuring this in little squares. Like theoretically, I could have divided this up into little squares. And so we're looking at square inches. How many squares fit on the inside? Okay? So that's pretty simple. Pretty simple. Okay. So now we're going to look at triangles. Okay? Okay, so with triangles, it's a little interesting. I actually want to start over here on the flap because it'll be a really easy way to explain this. And I'm sorry, you can kind of see the edges of where I was cutting and pasting. But with a triangle, we're going to think of it as being half of a rectangle. Yes. So over here on this right triangle, I'm going to draw a little line up and over, and I will get 2 identical triangles that have the same measurements. And to find the perimeter is the same as it always is. So let's do that first. If I want to find the perimeter of this triangle, what would I have to do?
Add it all.
Add it all up. Please raise your hand. So we're going to add it all up. So for the perimeter, we're going to add 10 and 6 and 18. So 6 and 8, I'm sorry, 8, not 18. So 6 and 8 make 14 plus 10 would be 24 inches. So that's the perimeter. Perimeter is pretty easy. Just add them up. For the area, though, we're going to think of this as being half of a rectangle. So if I was finding the area of this whole rectangle, which numbers would I use for the length and the width? Yes?
6 and 8.
6 and 8. Now, on a triangle, we often call that the base and the height instead of length and width, but it has the same ideas. And so to find the area of a rectangle, we would just take that number times that number and be done. With a triangle, we want half of it. And so one way to write the formula is base times height divided by 2. Sometimes you will also see, I'm going to put it in parentheses, 1/2 base times height. Sometimes they'll write it that way, but both of them mean the same thing. It's half of the area of the rectangle. So what we're going to do to find the area for this one, I just realized I didn't mean to do this the way that I did it, but it's okay. So the perimeter is 24 inches. I'll box that. This is my area formula. So to actually find the area, I'm going to take 8 times 6 and then divide it by 2. So 8 times 6 is 48. If we divide that by 2, we get 24. And we get 24 inches squared. It's actually kind of weird that we got 24 for the area and for the perimeter. That doesn't normally happen. It just happens to be that this is a special situation. Okay? So that whole idea of the rectangle, strangely enough, works for any kind of triangle. It's just a little bit weirder on some of these. So on this one, you would have to draw lines up on the sides. If you want to do this lightly, you can, or you can just watch me if you think it's going to be confusing on your notes. And what we would end up with then is two pieces that are identical to these two pieces that are inside the triangle, and those would add up to the same area as this, so it's still half. It's still half of a rectangle. Okay, so let's start with doing the perimeter of this triangle first. So this 4 yards that's on the inside, we're not going to use for perimeter. Okay, we are going to use it in a second for area. We're not going to use it for perimeter. So for the perimeter, we're just going to use the numbers on the outside. We're going to add up 6.6 and 5.5 and 9. We're going to add all of those together. And this is a good time to save some time to use the calculator. And I got 34.6. Did I do something wrong? Oh wait, I'm looking at the wrong problem, so yes I did.
Well, you added 9 from the bottom.
Okay, so yeah, I think I did something wrong. So let me calculate that again. So I'm going to do it. 6.6 plus 5.5 plus 9. I think you're right. So 21.1 yards is the distance around the outside of that triangle. Okay, now for the area, we have to think of this in terms of, the rectangle. So if I was doing a rectangle, 9 would be the length, and this 4 yards here you could drag over here, that would be the width. And so basically we're going to use this number and this number, the base and the height, not the slanty numbers. So on the base and the height for a triangle, they're always going to be perpendicular. That's why they have this little dashy line here at the right angle showing you the 4 yards. That's showing you how tall the triangle actually is. These slanty lines don't count. It's kind of like a mountain. Here around Lake City, we've got lots of tall mountains. They don't measure up the side of the mountain to figure out how tall it is. They actually use some math and figure out the height from like sea level, earth level, and they go straight up from that point on the earth. So to find the area here, we're going to take 9 times 4 and divide by 2. So 9 times 4 is 36, divide by 2 is 18, and so the area is going to be 18 yards squared. Okay? So let's do one more. Una más. Oh, and I left a number off to find the perimeter, but I'm going to put that on there here in just a second. Let me look and see what that would be. Okay, so this number right here, this solid line, should be about 5 centimeters. It rounds off to 5 centimeters. So what I want to explain on this, let me zoom in so we can really focus on this problem. The dashed lines are not actually part of the triangle that we're trying to look at. Okay? These are out here so that we can see the actual height off the ground level for this triangle. And we don't need that to do perimeter. So I'm going to cover all of that up with my fingers. To do perimeter, I just need to add the actual 3 sides. So I'm going to add 5 and 5 and 9. So 5 and 5 is 10.
19.
Add a 9, so it's going to be 19 centimeters all the way around that triangle. Okay? What I do need over here is the height number. So the base of this triangle is the 5. That's the base. The height of the triangle is not actually part of the triangle. It's how high that triangle kind of goes above the ground. And so this is the height. So when I do my area formula down here, and it's base times height divided by 2. I think we did like a chant or something last year with that.
I made that.
Oh, Bennett did. Yeah, it was Bennett's chant. Base times height divided by 2. So when we do that, we're going to take the base, which is 5, times the height, which is 3.9, and divide by 2. And let's use our calculators to make this a little faster. So 5 times 3.9 comes out 19.5. And then I have to divide that by 2. And we get 9.75. I'm just going to go ahead and keep the decimal for right now. So 9.75, and that would be centimeters squared. I'll box that since I have a lot on that line. Okay, so when you're doing the triangle, the base and the height are always going to be perpendicular. So this is horizontal, that's vertical, that works. But we didn't even use this 3.1 that's down here. That number is not important. We didn't use it for anything. It just happens to be a little bit of extra information that they put on the picture. Does that make sense?
Don't be tricked by the 3.1.
Don't be tricked. Okay. So that same formula works for all triangles, no matter how weird they are. It's still considered to be half of a rectangle or half of a parallelogram, which we'll talk about here in a second. Okay, so we're going to wrap this up. Parallelograms are a little simpler, so let's go over to the left-hand side of a parallelogram. Okay, so parallelograms are like rectangles that have been like pushed over. What I want you to visualize for a second is you see where they've drawn in this little dash line for the height, and it just happens to be at this corner. I could take this triangle and move it over here. I want you to imagine that. And then this part would be gone, and you could make this into a rectangle. We're going to use that for the area. I'm not going to use that quite yet. I keep getting ahead of myself. Let's just do the perimeter first. So the perimeter is all of the outside numbers. What number that's on here are we not going to use? Raise your hand. Tommy. 7.6 I'm not going to use for perimeter. I will use it in a second because that's the height. There are 4 sides and the top is not labeled. Oh my, what do I need to know to do this? Somebody else is awake. Are you raising your hand? Go ahead, Alyssa.
It's 12 yards.
It's going to be 12 because these have to be the same on a parallelogram. So I actually do have all of the sides. So I can add the 12 and the 12 and the 8.8 and 8.8, or you can think of it as 2 times 12 plus 2 times 8.8. I kind of like that because it's a little bit faster than writing down all 4 numbers. So 2 times 12 is 24, and 2 times 8.8 is 17.6. Why did I do the multiplication first? Raise your hand if you know. Bennett. Order of operations, multiplication comes before addition. So we're just going to add, then we can add these 2 together. I'm using my calculator to do that to make this a little faster. You get 41.6 yards. Now, if you want to write 12 plus 8.8 plus 8.8, you are welcome to do that and just add up the 4 sides. It's just a little bit more writing on your paper. Okay? I know you guys love to write out as much as possible. So if you want to do that, you're welcome. So what I was talking about with the triangle really affects area. Imagine I took this triangle off and moved it over here and made it into a rectangle. Well, then I know that the length is 12 and the height is 7.6. So you can kind of imagine this rectangle right here, and we took the triangle off. And then I would have 12 and 7.6. Oh my gosh. So the formula for a parallelogram, if you don't want to redraw that, I'm just kind of showing you where it's going to come from. The formula for this, the way that we label things on the parallelogram, is these 2 parallel sides that are perpendicular to the height are called the bases. So this is a base, and then this that goes straight up is the height. And so for the area formula, you take base times height. So there's a formula you may want to write down. And so for this problem, what we're going to do then is just take the 12 times the 7.6. So 12 times 7.6 is 91.2, and that'll be yards squared. It's going to go a whole lot faster on the next one. And I know that we may run out of time, and it's okay.
No, it's not.
That just means maybe I won't give you homework tonight because it's not your fault. It's just a long lesson. We've done really good with time. Okay, so on this next problem, for the perimeter, which numbers off of here do we use for the perimeter? Raise your hand if you know. You've done quite a few. Somebody else. Somebody jump up. Brian, which numbers do you think we'll use for the perimeter?
I don't know.
I don't know? Okay, I thought your hand was up. I'm sorry.
Wait, what was your question?
I know you know it. So which of these numbers are we going to use to find the perimeter? We're not going to use all of them. Or should I ask, so go ahead, Rhett.
8.1 and 7.
8.1 and 7.1, because this goes across. This is also 7.1. This is also 8.1. This is not in my parallelogram. I'm not going to use that. So for my perimeter, we're just looking at the outside of this parallelogram. So I'm going to have two 8.1s. I'm going to add to that two 7.1s. So I'm going to take 2 times 8.1, that'd be 16.2. 2 times 7.1 would be 14.2. And if we add that, we get 30.4. So 30.4 kilometers is the distance all the way around the actual parallelogram. I know that that's the actual because those are all solid lines. The dashed lines out here are separate. So on this picture, instead of drawing the height in the middle somewhere, they drew it out to the side, which sometimes they'll do just to not have everything in the middle of the picture. So for this picture, which number is the base of my parallelogram? Go ahead, Tommy. 7.1 is my base. What is my actual height? Somebody else. This side of the room is really quiet. What's the height of the parallelogram? Red.
6.4.
6.4 is the actual height. So even though it's not on the parallelogram, that's how high it actually is. So we're going to take those numbers and multiply them. 7.1 times 6.4. And we get 45.44 kilometers squared. What if it asked me to round to the nearest tenth? How would I round that 4? I could just leave it as a 4 then. Because on most of what we've been doing, they'll ask for the tenth, so we could just take that other 4 off. And we could write down here what it was, just so we know. Okay, and then we make sure that we put the squared on the area.
It's a big trapezoid.
It is. Okay. Let's look at trapezoids. Everybody's got that? Hopefully. So trapezoids are kind of funny shapes. This first one, and when I look at it, it looks like somebody took a rectangle and slapped a triangle on the side. Doesn't it look like that? That's how we're going to deal with the area. But let's do perimeter first. So perimeter, all 4 sides are different. So we're just going to add them up. 2.7 plus 2.3 plus 5.3 plus 6.9. And when we're adding long strings, that's when a calculator is an appropriate tool to just make this go a little bit faster. We do know how to add them by hand, but if we don't have to, that's great. I'm going to make sure I typed all my numbers in my calculator correctly. I did. We get 17.2 miles. So it's just the distance around the outside. You just add up all of the sides. For the area, we're going to think of this as 2 different shapes. So to start with, when I broke this up, I have a rectangle over here. How do I find the area of a rectangle? Silas? 2.7 times 2.3, good. And so we're going to do that to find this. So 2.3 times 2.7, 2.3 times 2.7, I get 6.21. I'm just going to write that in the middle so I'll keep track. And I'm not going to round it off till I get to the last answer. So that part has 6.21 square miles. And then this triangle over here, the base, I only want part of the 6.9. So if I realize that this little piece over here is 2.3, I could subtract and figure out what this little piece is. So what is this little piece over here? Raise your hand if you want to help me out on that. Go ahead, Tommy.
4.6.
4.6. This is 4.6, and that would be the base. What would be the height of my triangle? Go ahead. 2.7. So if you want to, you can copy those over here. And so with triangles, remember it's half of a rectangle. So we're going to take 4.6 times 2.7 and then divide by 2. So 4.6 times 2.7 is 12.42. If we divide that by 2, we'll get 6.21. So that's what this piece right here is. And then I have to just add those areas together. I'm going to do that down here. It's getting really messy. So the first rectangle was 6.21. The triangle came out also 6.21. Weird coincidence. So we get 12.42. And then if I want to round it to the 10th, that's just 12.42. miles squared. So you can figure these out by breaking them into rectangles and triangles, breaking them into shapes we already know how to solve. Okay? Alrighty. We're just going to go ahead and finish this up. I'm not going to give you homework tonight. We'll do it tomorrow in class because I knew this was a long lesson. I kind of had that in my mind. I just made this foldy. I wasn't sure how long it was going to take, but it's okay. So let's take a look at this one. All right. So this is what we call an isosceles trapezoid. Why do you think they call it isosceles? Rylan?
Because two of the sides are the same.
Because these two sides here are the same and the other two sides are not. So it's like isosceles triangle. You have two sides the same. This is isosceles because these two sides are the same. And that's kind of important because that lets us know that these angles are going to be the same. It makes a lot of things identical.
And the triangles are going to be the same.
And the triangles are going to be the same too. And so there's a little bit of a trick that we can do with this one. If we think about it, do you see how they drew the height over here and made this little triangle? We could actually imagine flipping that around and pulling it over here and redrawing it over here and making this into a rectangle. Can you visualize that with me? Because then this little piece and that little piece kind of add up. And look, it's a rectangle. So we're going to do that for the area. And I got ahead of myself again. I should still do the perimeter first. So the perimeter, we're going to add up all the sides. So if you want, you could write 2 times 9.8. It's a little shorter than 9.8 plus 9.8. And then add the 4 and the 12. I'm not using the 9. Why am I not using the 9? Because that's the height. It's inside. Perimeter is the outside. So we're going to add up all of that for the perimeter. So 2 times 9.8 plus 4 plus 12 is 35.6. So my perimeter is 35.6 centimeters. I'm just checking my label. And then for the area, if I take this triangle over and slap it over here, and then this part's gone, then I'm just going to take length times width. So my length would be 12, and my width or my height, whatever you want to call it, would be 9. Oh, I'm sorry, did I go off the screen? So we'll have the 12 and the 9, and we just get 108 centimeters squared. So it's kind of fun to think about how we can rearrange parts of these to come up with the area. So really quick, before we leave, we need to glue this foldy on page 98. That way it is not lost when you come to class tomorrow. You should always have your math notebook and you will have it. Glue it to page 98.